Hi, this is Jeff Evans from Evans Performance Academy. We're going to be taking a look at some basics with our PC Link software so you can get started with your Link G5 or G4X system. Without further wait, let's jump in to check this out. Okay, so let's get started. We're going to be taking a look at how to set up pressure sensors within our Link G5 and G4X programming. Now, setting up pressure sensors is something that we absolutely need to know how to do. Map pressure sensor is one of the most basic yet very vital sensors in terms of our programming with our Link. We're going to take a look at setting up a map pressure sensor in this training module. Then we're also going to be taking a look at setting up a fuel pressure sensor. Now, other pressure sensors might be exhaust pressure, oil pressure. You can also set up some custom inputs that may not be defined within the software, so we can set up other types of pressure sensors. You might be wanting to take a look at coolant pressure. Pressure sensors all work the same. They're going to be a linear scaling, meaning they're going to have a min and max volt and a min and max pressure that we have to input to the software to calibrate it so that the sensor and the channel reads correctly. So how we set up a map pressure sensor is going to be essentially the same idea as doing a fuel pressure sensor, but I am going to go through both examples in the training module so we have a clear idea how to accomplish this. Now, where I'm at here with my G5 system, I have it wired into a Honda K-Series engine through custom wiring. And in this case, I know what all the inputs and outputs are going to be for my harness because I've wired it. I need to assign them to my Link G5. The G5 is a universal box, meaning it's not going to be a vehicle specific. So I need to go now take the universal generic file here that Link gives us for a G5 and start defining specific things for my wiring and my sensors that I have and I'm working with. So in this case, we're going to be taking a look at setting up an Omni 4-bar map pressure sensor and an AEM 0 to 100 PSI fuel pressure sensor. It's pretty straightforward how we do this. Let's take a look here at a couple key things. First things first, we're going to go in here. We're in our basics page. This is going to be our custom layout for the training course. Again, I'm going to be using this in all the training tutorials. We're going to move from our basics page over to our analog input page or the AI page. If we click on this, this is going to allow us to program and set up all of our analog type of inputs. This is going to be for temperature sensors and for pressure sensors. We can find that Link defines the more commonly used type of sensors here. For example, in this window, ECT, engine coolant temperature, or intake air temperature, these are pretty common sensors. We have to have them wired into Link to allow the proper fuel and spark timing calculations. We also find things such as our map pressure, throttle position, lambda, baro pressure, fuel pressure, oil temperature, exhaust pressure. We also find some other additional things, fuel temperature, math meter. So we have the ability to go in and set up these essentially predefined common type of sensors in the software. We also have the ability to set up other types of generic pressure or temperature sensors. So for example, we have GP pressure, general purpose pressure. We can give this a custom name and set our calibration details if we want to set up something that's not found already predefined in the software. So if we want to do coolant pressure, that's not something that we find in the software here in our various options. We can add that in here, and same thing with temperature. Maybe you want to go in and have a differential temperature for your rear differential. You can go in and put a temperature sensor in the differential to monitor your differential temperature for racing conditions. You could set the label here and go through and program that. What we're going to cover here in our analog inputs, again, is our pressure sensor inputs, and specifically map pressure sensor, which is our window right here, and fuel pressure. Again, we can add in all additional sensors and fill up as many channels as we like, as long as we have enough inputs available for the Link. But this is where we're going to program and set up all of the analog inputs. Now, let's take a look at setting up our map pressure sensor. Now, I happen to have the wiring schematic for the wiring harness I made for my vehicle and my G5. So I know where I've wired certain features and functions, sensors, and all that information. I have my map pressure sensor found on analog input 2. And we're going to be assigning that here under our source. This assigns where we've wired our actual sensor to. Then I have my fuel pressure sensor wired to analog input 3. So I'm going to be assigning that here under the source. Again, the source is going to be what input we've wired our sensors into for the Link. Now, if you didn't know for example, where you have something wired on the link. There is a way to tell. So if you didn't get a wiring schematic for your vehicle, if you're unsure of where something's wired, you are able to do a check on this. We're going to be using our runtime value option to see the raw analog voltage and figure out potentially where your sensor is wired to, whatever you're trying to assign. If we go up here under tuning, we have this option here. We can click F12, which is the keystroke to bring up our list, or we can go down here for the drop down. If we click in our runtime values, this is going to show us all of the runtime values for every single channel coming in to the link in terms of our sensor wiring. It's also going to show us any features or functions that are present. We can see all kinds of information in here. So for example, we can see what the E throttle is doing, or the knock control is doing, or the variable valve timing. Again, there's a tremendous amount of information that can be found in our runtime values. It's super valuable window here to take a look at. Now specifically, because we're talking about our analog input types, I want to go in and figure out which channel, let's say if I didn't know this, which channel is associated to the sensor that I'm trying to configure so that I'm able to assign that correctly under the source. If the source isn't assigned correctly, the sensor that we're trying to work with here in the software will not read correctly, and it's just going to give you issues. So if we go back here a little bit and we scroll to the window here called analog, this allows us to take a look at all of the analog inputs. Now we can see here for my G5 box, analog input, I have analog 1 through 14. We can see analog 4 through 14 has 0 volts in it because these aren't doing anything. Right now I've only had 3 analog inputs that I've configured for various different options, so pressure sensors and a wideband. We're going to talk about that in another training module, setting that up. So in this case, I know that my analog voltage 2 is assigned to my map pressure sensor. The map pressure sensor is plugged in right now, so I'm key on, engine off. We'll find that that is going to be the voltage it outputs. If I wanted to test, if I was unsure where my actual map sensor was wired into, so again, we're in the situation we don't know, let's say hypothetically, we don't know where something is wired to, you could unplug the map pressure sensor and the voltage would drop to 0 on whatever channel is associated to where that sensor is wired into. That'll give you a very quick and easy way to determine what actual analog voltage input is being used or should be used for that particular sensor. Now, again, if you're wiring it in, you're going to be paying attention to where you've wired it to the link, but that is a situation I've been in a couple different times where I have a vehicle come in, somebody has things wired in, they're not defined in the software, and the owner of the vehicle doesn't know what was done from another shop. And that's how I usually go in and take a look here. So I'll pop into the analog runtime value list and take a look, unplug the sensor, figure out which one drops the 0 volt. Then I know which is going to be the actual sensor, and to assign it, I can go from there. Okay, so we know analog voltage 2 in my case, because I've written it down in my documentation for my pinout for my wiring, is where we want to assign our map pressure sensor. So we're going to go here to the source in our list, and as I was mentioning, this allows you to assign the actual analog voltage channel that you've wired it into. Again, I know mine is going in here to analog voltage 2, but we do have the list here all the way down to 14 as options. In this case, I'm going to choose 2. Now, we do have a couple additional things to take a look at here. We're going to find we have an error, low and high, and we're going to talk about this a little bit later. This is something we definitely want to assign, because if the map sensor comes unplugged, we want the link to be able to flag that as a potential fault code, or for some reason, if there's some kind of a wiring problem and you go above the 0 to 5 volt, so a map pressure, any pressure sensor here coming into the link is going to be a 0 to 5 volt total scale. It's not going to go above 5 volt. It's not going to go below 0 volt. We want to go and set the trigger for the error detection for the map pressure sensor for when it gets too low a volt or too high of a volt. But this depends on the actual scaling for the sensor we're working with. We're going to be taking a look at a data sheet to enter some of the information in here to configure and set this up. All right, so right now we're going to leave this alone. The error value, this is associated to when it faults, so if it goes below this volt or above this volt, what it's going to default to. Right now it's set to 0 kPa, so that'd be what the map pressure sensors are going to read if there's a map pressure sensor fault. We'll also discuss that. Now moving over here from our error value, if we just jump down to the bottom of the window, we have here filter, And the filter is going to be three different options. We have a low, medium, and high for the filter. We generally want to run the map pressure sensor on the low filter option. That's going to be how the map sensor is sampled over a period of time. If we're finding that our map pressure sensor reading is really erratic, that could be a bad vacuum source from your intake manifold. That's typically where we're going to draw our vacuum from, somewhere between the throttle body and the intake port. But you'll find that sometimes you get an air resonance in the intake manifold causing a real choppy map pressure reading. That can lead to a lot of fueling and spark timing problems. We want to avoid having an erratic map pressure reading. Some situations, maybe that's the only vacuum source that you have. In that case, then you would want to go in and set it to maybe a low, from the low to a medium or a high filter. Be aware when you do this, this will cause a longer period of time of filtering, which causes the map pressure sensor here to have a slower response. And as a result, we're going to find it's going to have a lag in the fueling, especially with acceleration enrichment. When we hit the throttle, it's not going to apply acceleration enrichment as easy. And as a result, you'll find that you have to have a lot more acceleration enrichment. And overall, it's just not that desirable to have that filter set too high. So the most I've ever had to do here is use the medium setting on, I think, a few different engines in the past. Typically always going to use the low setting. And if I'm getting an erratic map pressure reading, I always try to relocate the actual vacuum source of the map pressure sensor whenever possible. A lot of times we can take care of the actual map pressure reading if it's erratic, again, paying attention to it. We can do that by not applying a filter here. Virtually, we can actually just simply move the vacuum source. So the filter I'm going to leave on low for right now because it's typical of what we have to do here. Now, the next thing is setting up the actual calibration for the map pressure sensor. So this is going to require us to look at a map pressure sensor data sheet. In this case, I'm using an Omni 4-bar map pressure sensor. These are pretty common sensors found on a lot of Honda K-Series engines. A lot of people use a plug and play. In this case, we need to go in and configure this in our calibration here. Now, let me talk about the calibration window. This provides us a simple drop-down menu. If we're running a map pressure sensor, for example here, that's in the drop-down menu, we don't need to do any further programming. It's as simple as selecting the map sensor in the drop-down. We can see there's quite a few Bosch sensors listed here. There's some stock sensors, stock Honda sensors, for example, for map pressure. Again, going down here, we have a lot of OEM type of map pressure sensors. Then we have here calibration tables. There's a cal table 1 through 10, and then there's going to be 3 linear calibration tables. The linear calibration tables are what we want to use for a map pressure sensor and for typical pressure sensors such as fuel or oil pressure, again, if our sensor we're using isn't in the drop-down menu. Now, my sensor, the Omni 4-bar map pressure sensor, is not found in this particular drop-down menu. So in this case, I'm going to have to go in here and jump into our linear cal table 1, 2, or 3. I have to know what the minimum and maximum output voltages are for the sensor and what the minimum and maximum pressures associated to those min and max voltage ranges are going to be in order to set up a linear calibration table. Let's do that right now. So I'm going to go select this option and click OK, and it's going to tell me I have to do a map sensor calibration after I've set it all up. We're going to do that. Let's just click OK for right now. Let's go here into the label, and in this case, I'm going to give this a custom name. So the linear cal table, the setup is going to be found in this window. We've selected it here. Now we're going to go to here in the software to set this up. So here I'm going to go and set it as a custom name. I'll say Omni 4-bar, so I know what this is associated. We can see that it's going to be tagging that in here when we're looking at this linear cal channel. The next thing here is we have a input in A and B value, and then we also have output A and B. As I was mentioning, pressure sensors are a linear style sensor. They have a minimum and maximum voltage and a minimum and maximum pressure reading. We need to input that to our values here. So the input value A is our minimum voltage. The output would be then the actual sensor reading at that voltage. So minimum volt, minimum pressure. And then we have our input B. This would be the maximum volt output from the sensor, and then the actual maximum pressure sensor reading from the map pressure sensor. Now the output units are important here We want this to be set to pressure because we're dealing with a map pressure sensor, so we're going to go ahead and select that and click OK. Now the next thing here is we need to go into the data sheet for the map pressure sensor we're working with and find the information we need to enter in here for our input value A and B voltage, and then the output value A and B for the kPa, or in this case, that's going to be our pressure scale reading. Now, if you're not comfortable working in units of kPa, you're more used to working imperial or standard units, we can switch this very easily from units of kPa to PSI by simply going in here and clicking the U button. We can see when I click U, it switches us over to PSI. If I click U again, it switches it back to kPa. This will switch you back and forth between imperial standard units and metric units. Let's go see what our data sheet shows, and that's what we're going to put in here. We want to make sure we're paying attention to the units that we're working with here and what the data sheet is listed in terms of the sensor data. So in my web browser, I have this page open here. This is associated to our Omni 4-bar map pressure reading. If we go down here, we're going to find various systems listed here. So here's AEM. We're going to go down here a little bit more here. There's Motec programming. What we're looking for here is a minimum and maximum voltage and a minimum and maximum pressure reading. That's all we care about. So we don't necessarily care about the various different sensors that we have here. Right here, if we pay attention to this page right here, we're going to find that we have our input voltage. That's what's listed up here on the top. So we can see our very top. So that's voltage. And then in the middle row here, we find kPa. We also find PSI. But for right now, I'm going to just work in kPa. I think it's a little bit easier for programming this. This is saying here at 0 volt, again, that's our top row here, we have 0 kPa. So that makes setting up this map pressure sensor fairly easy. If we jump in here to our link, 0 volt would then be an output value here of 0 kPa. Then, jumping in here, we need to know what the maximum output voltage is going to be, and then the maximum pressure in units of kPa. So if we go back in here to our data sheet, we're going to find then, if we look at the top scale, 4.799 volt is associated to 400 kPa, or that's where we get a 4-bar from, the Omni 4-bar sensor. So if we jump back in here, we're going to go and set that up. So we're going to type in here, in this case, 4.799, enter, and then the output here will be 400 kPa. So that's simple. What we're going to notice is, in this case, my engine is off, so I'm key on, engine off. We're connected to the link, so we're streaming our data. Once I enter this information in here, we're going to notice the map pressure sensor is reading 96.9 kPa. It's moving around a little bit. So 96.8, 96.9 kPa. We'll find that when we're key on, engine off, and we're approximately at sea level, this should be anywhere from 100 to 102 kPa. Now, I'm about 800-900 feet of elevation at my location right now for filming. We're going to find here that we have our onboard baropressure sensor. We can find that right here in this window. The source is set to internal. All link boxes have an internal baropressure sensor. What we're going to find here is that the baropressure is showing about 97.1 kPa. There's a discrepancy there. Key on, engine off, your baro and your map sensor should be identical to each other in reading. Now, because we're entering in calibration data and there's always a small margin of error for each sensor, so anytime you get a different sensor, it probably is going to be slightly different when you plug it in, even with the same calibration scale, we need to perform a map sensor calibration. It's pretty straightforward how to do this. We can go here to the little icon in our window here. If we double click, this is going to say, do you want to perform a map sensor calibration? Now, what this is going to do is compare your baropressure to your map pressure reading. Obviously, we have a discrepancy here. What this is going to do is use the scaling that you've placed here in the software, but make an internal check between these two, and it'll automatically adjust the offset difference between these. So we don't need to go in and actually try to adjust our scaling so that these are identical. It's going to do that process for us already. Let's click yes and give that a second. We can see here, map sensor calibration completed successfully. So it's telling me that everything looks good here. And we can see now the map pressure and baropressure are matching each other, which is good. I believe there's about a 5 kPa allowance between the baro pressure and map pressure reading, meaning if it's outside of that window, say we put our calibration data in here and the map pressure sensor is within, let's say it's 10 kPa or 8 kPa off from the baro, it won't calibrate. It's going to tell you that you either have a bad sensor, your sensor scaling is incorrect, or your wiring is wrong. So it does that so that it doesn't automatically try to use some kind of a skewed map pressure sensor reading. This is putting a logic check on the map pressure sensor. Because this pressure sensor is used for fuel and spark timing calculations, super important that the sensor reads correctly and that it's calibrated correctly. So this is one step that we've already completed now for getting a first pressure sensor to configure and set up for the link. If I click OK here, we're going to find that we're good to go. Now, let's take a look at a couple things. We're going to find here that we have an analog 2 low error and a high error. This is where we're going to have a little bit of a snag with this map pressure sensor. We're going to find the minimum voltage according to the data sheet is 0 volt. We're going to say in this case that our low error has to be set here to 0. Now we're never going to get this low of a reading out of the map pressure because this is full engine vacuum. 0 kPa is the equivalent of negative 14.7 psi of engine vacuum, or the equivalent of about negative 29.4 inches of mercury. So we're never going to pull that much vacuum in our engine. That's the lowest that we can possibly pull. We should be fine with the low air being parked here at 0 or even 0.05 volt, because again, we're not going to pull that low of a vacuum reading on the map pressure sensor, and the voltage should never get that low. What we're going to have to do in this case is set now our high air, and if we take a look, the peak voltage out of the sensor is 4.799 volt. I'm going to set this slightly higher at 4.85 volt so that if the map pressure sensor becomes unplugged and it gets a high voltage or a low voltage, or there's a wiring problem, let's say we somehow get the 5 volt wire touching the signal wire, it'll feed 5 volt back into the link. If it gets above this voltage, it will flag it as a map pressure fault, and then it'll go in here and use the error value. This is what's going to default to. What I would recommend here is putting the default value at something like 100 kPa. You can set it to wherever you like, but that's what the map pressure is going to read in its fault condition. Hopefully it makes sense. So it's pretty easy to set up a map pressure sensor. We just need to make sure that we're paying attention to the details. Again, we want to make sure that we're paying attention to the data sheet we're using for our sensor, what those units are going to be, and paying attention then to the min and max voltage range for the sensor. Let me go ahead and perform a store so all of this information is stored onto the link. So if I power the link off and power it back on again, the data here will be present on the link. Let's do a Control S. We can see it's performing a store and the store is completed successfully. So now our map pressure sensor is set up. We know it's calibrated to the baro. We're good to go. All right, the last thing we're going to cover here is going to be our fuel pressure sensor. Now, this would be applying the same way we're going to be setting this up would apply to an oil pressure or an exhaust pressure or even a general pressure if we wanted to set up coolant pressure or some other type of pressure sensor reading. I'm going to go in here the same way we set up our map pressure, go to the source. This is where I need to go in and verify and set up what the analog input we've wired the signal wire from our pressure sensor into the link. So in this case, I'll go ahead and set this up on analog voltage 3. Now, low and high error, we have to program error value. If it faults above or below what it's going to default to, then we have to set up our calibration information. Now, in our calibration information, in our dropdown, we can find here that I do have a 100 psi sensor. I could choose this option, but I want to make sure that I have the scaling correct for the AEM sensor. We'll find that this is applying to a Honeywell sensor. In my case, I'm using an AEM sensor, and we're actually seeing here Honeywell/AEM. So in this case, it's actually going to be relevant. So we don't need to set up, in this case, a linear calibration option. We can simply select here the 100 psi option here. Let's click OK because it's Honeywell AEM. That's what I have. And then in this case, the next thing we need to take a look at is what the actual fuel pressure is reading. Now, in this case, I have 153 kPa of fuel pressure. This is not correct. If I actually click here click U, we can see that it's going to show us that's 22.2 psi at fuel pressure. There must be some residual pressure left in my fuel system, or the sensor is bad, or there's a wiring problem. But I was priming the fuel pump doing some testing, so I probably have some residual fuel pressure in the system, which is what the sensor is picking up. We want to see if the sensor calibration is correct. So the sensor is good, the wiring is good. Key on engine off, where you don't have any, the fuel pump wasn't priming and priming the system and pressure built. You should see this is sitting at approximately 0 psi, or in this case, 0 kPa. We can see that's the translation between kPa and psi. Just clicking the U button, we can see what that's reading. So this looks good. I'm not going to have to go tweak and adjust this. Now, the next thing we have to go in and do here is quickly set up the low and high trigger voltages, so the low voltage or the high voltage thresholds, and then the error value, what we want it to be associated with if it stops reading. So in this case, I know the scale for my AEM 0 to 100 fuel pressure sensor. I looked on their PDF data sheet. I don't have the copy of that pulled up here to take a look at, but it's going to be at 0.5 volt is the minimum volt, 4.5 volt is the maximum volt. So pretty simple there. That's what this calibration scale is already taking into account. At 0.5 volt, it's 0 psi, and at 4.5 volt, it's 100 psi. So that's the scaling we're working with here. Knowing that, I would set my low voltage here, saying that 0.5 volt is the lowest that the sensor can output. I'm going to set that slightly below that minimum of 0.4. And then I know that 4.5 is the maximum voltage output for my sensor. I'll set this a little bit higher at 4.6. If my fuel pressure sensor faults, I'll go in here and I'll allow it to read 0 kPa. So if there's a fault or a problem, that's what it's going to default to, and it'll flag that as a low or high error. So this should be okay for the fuel pressure. Again, I'm going to do Control S and perform a store to the link. So this information now is stored permanently to the link unless I go in and alter or change this. So the map pressure sensor, definitely a little bit more complicated setting it up. We have a couple details we have to make sure we're paying attention to. Fuel pressure, oil pressure, other pressure sensors are a little bit easier to configure and set up. Again, if I'm setting up, let's say, an oil pressure sensor and I'm not finding in my drop-down menu the sensor I'm working with, I can use another linear cal option. We have two other linear cal tables that we can go here, set those up. Again, we have to know the min max voltage and then the min and max output from the sensors, and make sure you set your output units on pressure scale and set them up. Very straightforward, very simple. All right, that's going to be it for taking a look at setting up pressure sensors with our AEM. If you have any comment or questions on anything we cover in this training tutorial, thanks for watching our tutorial. If you're interested in learning more about how to tune your Link G5 or G4X system, check out the video description below where you can find links to our school, some promo codes to get you started and save some money. If you're interested in learning more about Link engine management products, also check out the video description below. That's going to wrap it up here. I hope to see you guys in our school.